Question 7. In the diagram below, triangle ABC, and remember those have little apostrophes above them. So, is the result of a transformation of triangle ABC, which don't have the apostrophes. So, ABC with the apostrophes, remember that's the image. The one without the apostrophes that I'm circling right over here is the pre-image. Question, what are we doing? Which algebraic representation best describes this transformation? So they're not telling us, hey, this is a rotation, this is a dilation. We got to figure it out, and we got to figure out what's actually happening mathematically. But let's look at this. I'll kind of zoom in for a second here. We start with, remember, the image, the pre-image, I should say, I'm sorry, the pre-image, A, B, C, right over here, is a larger triangle, and then the image that follows is smaller. So we start with a larger triangle, then we're kind of shrinking it down. What kind of transformation does that sound like? If you said dilation, yeah, you're right. That's some kind of a dilation that's happening. We got to figure it out. When you have a dilation that is going from larger to smaller, we have a larger triangle that I'm drawing in here. It is dilated down to a smaller triangle like this. You're always multiplying, so I'll put a little time symbol. I'll write the word multiply. But when you go from larger to smaller, you're multiplying by a fraction, okay? A fraction. Multiply by a fraction. Anytime you dilate something and it gets smaller, you're multiplying by a fraction. So go back to the answer choices real quick. Now, we know we're multiplying, so I'm immediately saying, hey, guess what? We're not subtracting this answer right over here for, what is that? That's C, right? Yeah, C. And then we're also not subtracting, adding right over there. So our choices say we're either multiplying by 2/3 or we're multiplying by 3/4. Well, we got to do some math to figure out the correct answer. All right, let's zoom back in. Well, like we did last time, I'm going to clear out some of this. I'm going to say, let's get some points and let's see where we are multiplying, all right? So I'm going to even erase this out real fast. Let's go for, I like a point that's easy to see, okay? A point that's real easy to see. I guess we can use the B for each one. So B for the large one is right here where that orange dot is. That is it. 4x and then 0y, all right? So I can write that down. I can write 4 and 0. Great. Now, where is the point B for the one that is the image, all right? It's right here, which is close, but it's at 3 and 0, all right? 3x, you move x first, then y is right at 0. So what are we multiplying by? It's a little trickier. Well, the 0 and 0 is not going to help you out, so don't worry about a 0, 0. But 4 into 3, 4 into 3. 4 times what is 3? Well, if you divided to figure out what you're multiplying by, if you take the 3 and make it 3.0, and you just divide by 4, the other one, all right, and you say, hey, what are we multiplying by? Does 4 go into 3? No. Does 4 go into 30? Yeah, 7 times. That's a bad 7, I apologize. 4 times 7 is 28. And we can subtract away here to borrow over 2. 10 minus 8 is 2. Bring down a 0 makes it 20, and 4 goes into 25 times. 4 times 5 is 20, so it's 0.75. So the dilation is by 0.75 as a fraction. Well, if you know real quick, that 0.75, is that 2/3 or is that 3/4? Yeah, it's 3/4. It's this one right here. It's B. It's the second answer choice. Not going by 2/3, okay? So this part right here, I agree, could have been a little more challenging, but certainly we're not going to consider the adding or subtracting that happened with C or D there.